In this video, we are learning regression lines and one example of regression line and coefficient of correlation. The meaning of regression analysis is a statistical process for estimating the relationship among the variables. The types of regression analysis are linear regression, simple linear regression, logistic regression, nonlinear regression, non-parametric regression, robust regression, stepwise regression. The meaning of regression is the act of going back to the previous place or state, return to revision. The introduction of regression is the situation there is a single response variable y, also called the dependent variable, independent on the values of set of inputs called independent variable x1 so on up to xr. The simplest type of relationship this variable is a linear relationship. Next comes to the introduction of regression lines. If this was the linear relationship between y and the xi, I equal to 1 to r, then it could be possible once the beta were learnt. In practice, such a precious is almost never attainable. The most that one can accept is that the equation could be valid subject to random error. The final equation of regression is y equal to beta naught plus b1 x1 plus so on up to br xr plus e. In this video, we can solve one example about correlation and regression lines. The problem is as follows below. Obtain the lines of regression and hence find the coefficient of correlation of a data. Data is as below: x 1, 3, 4, 2, 5, 8, 9, 10, 13, 15, y 8, 6, 10, 8, 12, 16, 16, 10, 32, 32. First we calculate capital X and capital Y, and then we calculate x into y and x square and y square. We have first calculate x bar equal to sigma x divided by n. Then we get x bar equal to 7 and y bar equal to 15. We have a formula of regression lines: y equal to sigma x and y divided by summation of x square into x. Putting all the values of sigma x and y and sigma x square, we find y equal to 1.7647x plus 2.6470, as well as x equal to 0.44y plus 0.3987. Then we have formula of coefficient of correlation: r equal to plus or minus root of coefficient of x into coefficient of y. Putting the values of coefficient of x and coefficient of y, we get r equal to plus or minus 0.88.